So here's part B. Again, g of 4 means take 4 and plug it in for x. So I'm going to have the integral. So here we go. The integral from 1 to 4 of f of t dt. And that means the area under f of x, or f of t, between 1 and 4. So notice here, here's 1. That's going to be the area of that trapezoid plus the area of that triangle minus the area of that triangle, because that second triangle is underneath the x-axis. So it turns out that this area, this triangle here and this triangle here, one's positive and one's negative, so they cancel each other out. So all I need to do is figure out the area of this trapezoid, and that's the average of the bases, so 3 plus 1 over 2 times the width, which is 1 unit, so 4 halves times 1, which is 2. Now I've been asked to find g of negative 2. Again, we'll write the integral. That's going to be the integral for, I'll write it up here, 1 to negative 2 of f of t dt. This is a very, very, very common kind of problem to see, especially in the free response section. So I have an integral. Here's the function. All I have to do is find the area under the function between 1 and negative 2, but notice these integral limits are out of order. So I'm going to start by rewriting this using the opposite. I'm going to have to switch the limits, which means I'm going to have to stick a negative sign in front of my integral. And now the integral from negative 2 to 1 of f of t dt is the area of that triangle. That's from negative 2 to 1. That triangle is above the x-axis, so I'm going to consider it positive. I'm going to have 1/2 times base times height. The base is 1, 2, 3. The height is also 3. And notice I have the negative sign in front, which is going to end up giving me a negative result. So this is the opposite of 9/2. Notice that triangle is above the x-axis, so we might have expected the area to be positive, but the limits are in the wrong order, which is what makes our final answer negative. So here we go. We're going to use a combination of the properties of integrals plus what we learned in the last section, which is the integral of a constant. So I've been told the integral from a to b of f of x has this value. I'm just going to have to stick that in my pocket and save it for later. I've been asked to evaluate this integral. So we're going to use the properties. Notice there's a sum here. So I'm going to rewrite that as the integral from a to b of f of x dx plus the integral from a to b of 5 dx. Well, the integral from a to b of f of x dx, I already know. That's a plus 2b. Now I'm going to need to add the integral from a to b of 5x. So remember, this is the constant function 5, y equals 5, so that means my rectangle has a height of 5. And it's going to have a width of whatever b minus a is. So a plus 2b plus 5 times the quantity b minus a, and which gives us a plus 2b plus 5b minus 5a, which simplifies down to 7b minus 4a. Our answer is C.